Good morning, ladies and gentlemen. This is Mr. Rowe. We're taking a look in Geometry Part A. This is Lesson 13, and we're going to look at rotations. Again, this is some information that's covered in the lesson. I'm going to tell you and reiterate some important things in words so that you can get a better understanding of what a rotation is. So a rotation is the same thing as a turn. So an object will be turned somewhere, either in space or on the coordinate plane. We focus more on the coordinate plane than we do in space. So let's take a look at what a rotation is. A rotation, and this is the notation for rotations. So right here is the notation. This is a rotation of x degrees around point P. That's what that means. Is a transformation that rotates each point in the preimage about a point P, called the center of rotation. That's important. Center of rotation about an angle measure of x degrees, called the angle of rotation. So let's take a look at exactly what we've got here. So for the pre-image point A, the segment PA will be the same as the segment PA prime, and then the measure of angle APA prime will be x degrees. Rotations are rigid motions, so that means they are isometry. That means that the length and angle measures are preserved. And rotations, if you just see the word rotate, assume that it means counterclockwise unless somewhere else it says to go another direction. So here is object ABC. That's triangle ABC. We're going to rotate the triangle 50 degrees around point P. So there's point P. So I need to pull out my protractor and I need to make an angle that is 50 degrees from each point so that I can put the points in the right place. Now these are sort of lined up. I know it's not going to quite look like it when I do the rotation, but those are kind of straight line points. So we're going to assume that that's the right rotation. So there is the rotation. So this object turns and comes there. And now some of these things that we saw here, like PA, so P from here to here is the same as from here to here. So those segments are congruent. Let's talk about rotations in the coordinate plane. There are some basic rotations that we're going to look at. Here's the first one, a rotation of 90 degrees about the origin. So now if you think about the quadrant, it's set up into four quadrants. Each quadrant would be a 90-degree rotation. So if we go 90 degrees around the origin, what do? We switch the x and y coordinate and we make the y coordinate its opposite. So for example, if we had just a single point, and that single point right there is 3, 1, and what we're going to do is we're going to switch the points. So we'll go 1, 3, but we'll make the 1 negative. So our point will be -1, +3 right there, just like that. Now, what if we go 180 degrees around the origin? Again, think about this as each quadrant being 90 degrees. So that would be a 90-degree rotation. Well, 180 would show up down here. So 180-degree rotation, same point. So we got 3, 1. What do? We just change the signs. So change the signs for that point. So that means our point will be at -3, -1. So right there. And then finally, we could have a rotation of 270 degrees about the origin. Now remember, 90, so if this is our original point, 90, 180, 270. You get back, that's 360. And if you go counterclockwise, I'm going to talk about that. They're the same thing, the opposite direction. So here is the same point, 3, 1. So this says to switch them, but make the x negative this time. So we've got 3, 1. We're going to make it into 1, -3. So right there will be that point. Now, if we look at a 90-degree rotation clock, this is counterclockwise. We assume counterclockwise. A 90 degrees counterclockwise is the same as a 270 clockwise. And then a 270 clockwise is the same as a 90 counterclockwise. 180 will always be the same. 180 is always 180. All right, so that's what rotations are. Take a look at these rules when you go to do your rotation. That'll make it a lot easier to do the rotations and find the points. So here's an example. We're going to complete the following rotation. We're going to rotate 90 degrees about the origin, this object, triangle FGH. So what are we going to do? We're going to use the points and those rules that we talked about. So the 90-degree rotation, remember we switch the X and the Y, and we make the Y its opposite. So let's look at each point. Point F right here is at -2, 0. So we're going to switch. Well, 0 will come first, and then we have -2 second. Remember, you've got to change the sign, but 0 is 0, so you can't change the sign for 0. So it's going to move to 0, -2, and right there is point F prime right there. So let's take a look at G. G is at 0, 4. So if we switch them, the rule will have -4, 0. So -4, 0 right there. Switching the points and then make the first one negative for this rotation. So that is G prime. And finally, H prime, 3, 0. We're going to switch to have 0, 3. And so there is the points of rotation. Just connect the lines and you have your rotation. So you see, and if you think about this, I can't do this right here, but if you were to turn the paper, if you turn this object, then that rotation you would see this object mirror up to this object if you were to turn it. That's why it's called a turn. So let's take a look at another example. We're going to complete one more rotation here. So this time we're going to go 180 degrees about the origin. So here is our triangle, CDE. Again, we're going to use the points. Remember, the rule is for 180-degree rotation, all you have to do is change the signs. So our first point is at 1, 0. Well, 1, 0 will just become -1, 0. So it's right there. So what about D? D is at 4, 3. 1, 2, 3, 4, 1, 2, 3. So we're just going to change those signs. It'll become -4, -3. So there's -4, -3, and that's D prime. And then finally, E is at 1, 2. So we're going to make those signs negative, -1, -2. And there's E prime, and there is the triangle rotated 180 degrees. So that's all there is to this. Just make sure you follow those rules that I gave you for the rotations. You can't mess this up in the coordinate plane. So let's take a look at rotations and reflections. So we have any rotation is a composition of two reflections across two lines that intersect at the point of rotation. So the angle of rotation is always twice the angle formed by the line of reflections. You see these same pictures that I'm about to show you in the lesson content. So here is the original object, PQR. And you see here, I've reflected it across these two purple lines to get to the final object R prime, or P double prime, R double prime, Q double prime. And you see that this angle formed right here is 70 degrees. Well, this is the same as a rotation of 140 degrees. So that's the actual rotation at 140 degrees. If you see, I could take this object, fit it right on top, and those two objects would fit. I've shrunk this picture just a little bit so it fit. But that is how it works. So this angle right here, 140 degrees, that is twice the measure of this angle right here that forms the two intersecting lines of reflection. And those lines of reflection always go through that center point. So let's take a look at one more thing. Let's show that a rotation of 180 degrees is the same as a composition reflection over the x-axis, then the y-axis. So we're going to pull that same picture that we just worked with. And this is the final this was the final rotation, 180 degrees. So we're going to show that it is the same as a rotation or a reflection over the x-axis. So we're going to reflect this over the x-axis, then over the y-axis. So C and C prime, since they're the same, since they're on the line, will stay the same on the point of reflection. Let's look at point D. Well, D is 1, 2, 3 steps from the x-axis. So we count 1, 2, 3, and there it is again. So there is D prime. E prime is 2 units from the x-axis, so we'll put it 2 units below the x-axis. And there is our reflection over the x-axis. Now, if you look, you can kind of see that these are reflections. If you look, but we're going to go ahead and finish up the reflection. So now we're going to reflect over the y-axis. So I'm going to move C prime. It's 1 unit away from the y-axis, so it'll be 1 unit on the opposite side. So there's C double prime. E is 1 unit away from the y-axis, so E double prime is 1 unit away on the opposite side. And finally, D prime is 1, 2, 3, 4 units away, so 1, 2, 3, 4 units away. And there is D double prime. And you can see that these points are the same. That's -1, 0. That's -1, 0. This is -1, -2. This point is -1, -2. And finally, this one is -4, -3. And this point is -4, -3. So this is showing you that a rotation can be written as the composition of 2 reflections. So expect a question about this in the lesson content. I hope this little short recording kind of gives you a little clarity about some of the things in the lesson content. If you still struggle with the content, please let me know in a teacher message or make an appointment for a help session.